Hello Year 10. So this week we're going to look at histograms, which is revision for all of you. So carrying on with revision of data representation. So the first thing to know is the difference between a bar chart and a histogram. Okay, people do get these things confused. A bar chart, a simple bar chart, has the frequency on the y-axis, and they're obviously very straightforward to read. Just look at the height of the bar to determine the frequency. Okay, can't do this with histograms. Okay, with a histogram, it is the area of the bar that tells you the frequency, and the y-axis has a frequency density. Okay, so the important thing to remember is to work out the frequency, you find the area of the bar, and the y-axis will always have frequency density. Okay, so let's look at how we would draw one of these from scratch. So if you're given this information, first thing you need to do is add a third column, frequency density. Okay, and because the frequency is the area, just like you would if you were finding one of the missing lengths in a rectangle and you knew the area, you do the area divided by the length or the width to find the length or the width of the rectangle. So it's exactly the same with frequency density. We do frequency divided by class width to find the height of the bar. Okay, so first one, 20 divided by the class width. To work out the class width, we just find the difference between the upper and lower bound. So 120 take away 100 is 20. 20 divided by 20, frequency density is 1. Second one, frequency is 25 divided by the class width, which is 20, gives us 1.25. 30 divided by the class width, which is 10. 25 divided by the class width, which in this case is also 10. And same thing for the last one. Okay, so once we have all our frequency density, you can create your histogram. Remembering that frequency density always goes on the y-axis. Okay, so here's an example here. And you'll notice that the width of the bars are not the same throughout. Class widths are often uneven. Okay, and we can find the area of each rectangle to find out the frequency. Okay, so for an example here, we've looked at this one already. The class width is 20, the height is 1, 20 times 1 gives us a frequency of 20. Okay, this one, the class width is 10, the height is 3, so the frequency is 10 times 3, which is 30. Okay, so this is a typical exam question. You'll come across this in maths and in statistics where you have to complete the table and there's some missing information. Okay, so the first thing you want to do is to find a set of information which is complete. So if we look here, we've got the class width, we've got the frequency, and we've also got the bar that represents that particular set of data. Okay, so that's a complete set of information. Okay, and the first thing we need to do is to work out the frequency density, because that will tell us the height of the bar, and it will tell us, and once we know the height of the bar, we can fill in the scale all the way up the y-axis. So in order to do that, we do frequency divided by class width. So 50 divided by the class width, which is 10, tells us that the bar has a height of 5. So we can fill that in. And then we just fill in the rest of the scale on the y-axis. Okay, we know that there's 5, well, effectively on graph paper it would be 5 centimeters is equal to a height of 5, so every centimeter is 1. Okay, and then we can use that information to fill in the rest. So if we look at this first bar here, we've got the class width of 5. We now know the height is 3, so to work out the frequency we simply do 3 times 5 and we get a frequency of 15. Okay, we can do the same thing here. We know the class width is 10, we know the height is 6, multiply those together and we get a frequency of 60. Okay, so part B then asks us to complete the histogram. So we've got a missing bar between 10 and 15. We now know that that has a frequency of 20. So we do frequency divided by class width, and that gives us the height of the bar, which is 4. And lastly, 15 divided by 15 is going to give us a height of 1. So we've completed the histogram. So the important thing to do is when you start one of these questions, you look for a complete set of information. Okay, so just flicking back quickly to when we started. Here we go. We had a complete set of information here. Okay, we had the class width, we had the frequency, which is the area, and we also had the bar filled in. So we were able to work out. So you're looking for a complete set of information so you can work out the scale on the frequency density. Okay, so I'm just going to look at one more thing. Click forwards. So interpreting histograms, as we've said, key things to remember is the area of the bar denotes the frequency and the frequency density is on the y-axis. And you can use this triangle just like a speed, distance, time triangle or density, mass and volume. You cover up the thing that you're trying to work out. So if you're trying to work out the frequency density, you cover that up, you would do frequency divided by class width. Trying to work out the class width, frequency divided by frequency density. And frequency is on the top, so if you're trying to work frequency out, you do frequency density multiplied by class width. One way of remembering which way round this goes is remembering that this sounds daft, but the words with, well, there's two words, it's always at the bottom of the triangle because two words is heavier than one word and it sinks to the bottom. That's how I remember it. You might find another way, it makes more sense. So this type of question, estimate the number of people who are taller than 150 centimetres. Okay, so basically taller than 150 is going to be this bar, which is a height of 2.5, that looks like, and a width of 10. So that's 25 people. Then this bar is also greater than 150 and it has a height of what appears to be 0.5 and a width of 40, which gives us a frequency of 20. Add those two together, 45 people are taller than 150 centimetres. Okay, this one asks how many people are between 120 and 150. It'll always say estimate because we're not working with exact values, we're working with grouped values. And sometimes it'll ask you, why is this an estimate? And that's the reason you would give, because we haven't been given exact values, they're grouped. So here we have a width of 20 and a height of 1.1. It's probably quite difficult to tell because there's no graph paper behind it. Multiply those together gives us a frequency of 22. And between 120 and 150 will also include this bar. So width of 10, height of 3, which is 30. Altogether, 52 people are taller than 52 people are between 120 and 150. Okay, there's an error in this here. Sorry, I didn't spot that when I was going through it. So this should actually say, just ignore this bit in red. This is people who are between 120 and 150 centimetres tall. Okay, so what I'd like you to do is the questions on MathsWatch. Okay, but before you do those, I'd like you to do one of these, okay, on graph paper if you can get it. You can get graph paper and print it off. If you have access to a printer, you can just download some graph paper and print it off. Failing that, squared paper ideally. I'd like you to do one of these histograms and answer the questions and submit it by means of a photograph, and answer this question as well and just write your answer to this question under the histogram that you've done for the previous question. And then there are some questions in MathsWatch. Okay, thanks for watching.